In this example, we're going to form the equation of a polynomial given some information about its graph. In this case, we're going to form the polynomial function. I use the word "the" because there's going to be one unique answer here, whose real zeros are given. They're negative 2.5 with a multiplicity of 2 and 4 with a multiplicity of 3. So now we're getting into the multiplicity, so we know what the powers on the factors are going to be. And this polynomial must contain the point negative 2, negative 6. So this extra point that it's going to go through will give us some information that will help us to solve for the leading coefficient. Okay, so the first thing I want to mention is the degree of this polynomial. The degree is going to be the sum of the multiplicities for the factors here. And so we're going to have a fifth degree polynomial. I'm going to write this out as f of x equals, now my factors are going to come from the zeros. I'm going to leave a little space here, and because I know this is a fifth degree polynomial, my leading coefficient, I'm going to write it in as a sub 5. That would represent the the coefficient of the fifth degree term. Then my factors are going to be x plus 2.5, because we always change the sign from the 0, and then x minus 4. Now the multiplicities are important. Again, those are going to be the powers on each of these factors. So the negative 2.5 has a multiplicity of 2, so its factor gets a power of 2. 4 has a multiplicity of 3, so its factor gets a power of 3. Okay, so that's the main structure of this polynomial. But I still need to know what this leading coefficient is going to be. So to do that, I'm going to plug in values of negative 2 and negative 6 for the x and y values respectively. Okay, so the negative 6 goes in for the y, or the function value. The x becomes negative 2. So as I look at this, I'm going to simplify it using the order of operations. So inside the parentheses first, so we're going to get negative 2 plus 2.5 is 0.5. Negative 2 minus 4 is negative 6. If I square 0.5, I get 0.25, right? 1/2 squared is 1/4. So this becomes negative 6 equals a to the fifth, or a sub 5 times 0.25. Now negative 6 cubed, well, the negative cubed is still negative. 6 to the third is 216. And then we're going to multiply 0.25 times 216. Well, a quarter of 216 is 54. So this becomes negative 6 equals a sub 5 times negative 54, due to the negative on the 216. And then if I divide both sides of this equation by negative 54 to free up the a sub 5, the double negative cancels out. 6 over 54 is 1/9. And so I have my leading coefficient is a value of 1/9. Now I'm not quite done. The question asks for the to form the polynomial function. So far I've found the leading coefficient and a general structure. Now I've got to put that coefficient back in to get my final polynomial. So my final polynomial will be f of x equals 1/9 times the quantity x plus 2.5 squared times the quantity x minus 4 cubed. Okay, so this is our final polynomial. It is the factored form of a polynomial that has real zeros at negative 2.5 and 4 with the corresponding multiplicities, and it also contains a point negative 2 comma negative 6.